Hello, good afternoon, everyone. I hope my screen is visible and I am audible. This week we are going to see stepper motor based problems. And the first problem is written on the board that a three-phase 24 poles EMS stepper motor is given. And we need to find the stepping angle for this motor. Okay, so Chitu, could you please let me know whether I am audible or not, or my screen is visible?
Yes, sir. It is audible and your screen is visible.
Thanks a lot. So this is the first problem. Okay, phase number of phases and number of poles are mentioned. We need to find the stepping angle for this configuration. So what is stepping angle first of all? So do you have any idea what is stepping angle here?
Sir, for each and every pulse given, the rotor will rotate for each step, sir, within a
Exactly,
specific angle. That is called step angle.
exactly. So what should be the equation for that or expression for that stepping angle? If I want to calculate, so in a whole cycle that is 360-degree divided by number of phases and number of poles. So it should be 360 divided by 3 phase into 24 poles. It should be 5 degree, isn't it? So for each step, the rotor should rotate for 5 degree. Okay. Any doubt here?
No, sir. It is clear.
Yeah. So let us move on to the next problem. Yeah, it is a theoretical problem that in an axial flux SRM, okay, magnetic flux flows through which path? A is radially outward from rotor to stator. B axially along the length of rotor. C axially along the length of a stator. And D radially inward from a stator to rotor. So which of the statements does make sense? Radially outward from rotor to stator. So radially it won't flow. Flux lines would not flow radially because it is an axial flux machine. So we could discard two options here. This one and this one, isn't it? Now we are left with only two options, axially along the length of the rotor and axially along the length of the stator.
Sir, is it actually along the length of rotor? Is that correct?
Mm, in answer, it is mentioned option C, but according to me, it should flow, through the stator and rotor because without coupling between the stator and rotor, how could a machine could do magnetic coupling. So ideally, flux should flow axially from the stator to the rotor, right? So I don't know. It is mentioned that magnetic flux flows axially along the length of the stator, passing through the rotor and back to the stator. So in the reasoning also it is mentioned that magnetic flux flows axially along the length of the stator, passing through the rotor, okay, and again back to the stator. So option C is correct as given, but ideally it should be, a whole statement that it is flowing from the stator to the rotor again to the stator, given that there are two stator and one rotor, or like some configurations should have been mentioned, but anyway. So if you see such kind of problem given in assignment, or you can discuss on the discussion form as well. Okay, you got my point, right?
Yes, sir.
Yeah.
Hi, sir.
Hi, Rajni. Yeah.
Sir, actually, you remember, sir, last week we discussed one question that is a commutator frequency. You remember I told that it's
Yes,
an
yes,
120
yes,
p. Like, sir,
yes.
the thing is, what happened? I used the formula 120 p, and I given the answer over there. It's a 333.33. That's a wrong, sir, answer.
Oh,
Yes, sir. I also got the same answer, like 333.33 hertz. But in assignment, it is given like the answer
600
is
and
wrong.
double, sir,
okay.
And the
666.
last question also, sir.
Okay, let me see the question first. Yeah, so this was the commutation frequency expression, right? 120A by P only. And the problem given here is 5000 RPM, okay, and 10 stator poles, 8 rotor poles. You are referring to the fifth problem, right? I'm not able to hear.
Sorry,
Am I?
sorry, sir.
Yeah.
I'm in mute. Sorry. Yeah, correct, sir. It's the fifth problem. Speed is
Yes,
5000 rpm. Stator poles are 10. Rotor poles are 8. Correct.
yes, yes. So what should be the answer? Let me calculate. And this 5000 into rotor poles are 8 divided by 120.
जी, जी,
10. Yeah, it would come around 300 something, right?
Yes,
334.
333.33. That's what we got as an answer. But in assignment, they given 666. Actually, exactly, I told you, na, instead of 120, if you took 60, na, it will come.
Oh,
Not only that question, sir, there is one more question. That one also, I don't know what is the wrong in that. They just, it's wrong only for me.
which one is the other question?
Finding the stator height, sir.
Oh, finding the stator pole height. Yeah, we also solved that similar problem last time. Stator
We got
height. So yeah, this one, right?
8 to 10.
Data was also same or not?
Sir,
Data
data.
was same.
Stator height, pole height, stator pole height. Yeah, so I believe you must have calculated correctly, but you have verified again, right? So please post this on the discussion forum. I think someone is replying from the NPTEL side. Okay, you post that problem there. Okay, so these two questions have the issue, right?
Yes, sir.
Yeah. Anyway, so uh, we can discuss there. You just pose problems there.
Hmm.
Apart from that, I don't think anything could be done from my side. They will take care of it.
Okay, sir. We'll post all.
Yeah.
Yes, sir.
Yeah. Okay, so let's move on to the next problem. A hybrid VR stepper motor is given. It has 10 main stator poles and it has again castellated to have 4 teeth. So each stator pole has 4 teeth inside the pole, okay? And the rotor has 50 teeth. A stepping angle we have to find out here.
Yes, sir. 10 put 4.
So what is the expression of a stepping angle, beta?
It's a rotor poles minus stator poles by rotor poles into stator poles into 360 degrees, sir. Whole sum.
Exactly, exactly. So how much is the rotor pole here? 50. Regarding a stator pole, how much is it?
Stator poles are 10.
10. 10 is there, but how much value we should plug in here? Because, you know, it
40,
has
sir.
again
40.
castellated, yeah.
40.
So 10 into.
Sir, at 1.8 degrees, sir.
Exactly, 1.8 degrees.
Sir, 1 second. In
Yeah.
downside, not plus, na? NR into NS, no?
Oh, sorry. Yeah, yeah. NR into NS. So now 49 is 1090 divided by 50. So yeah, still it is coming 1.8. Okay, any doubt, Chitu? You got it?
Yes, sir.
Yeah. So let's move on to the next problem. Two phase, two pole, GM stepping motor. has number of turns per phase 1000, and it is loaded with external torque. TSH is equal to 0.15 Newton meter. Okay. Motor is fed with rectangular waveforms of magnitude. So the magnitude is given as IA is equal to IB. Both phase currents is equal to 2 ampere. And only one phase is fed at a time. Okay, inertia is given 2 into 10 raised to power minus 4 kg meter square, and acceleration is applied from omega 1 is equal to 100 radian per second to omega 2 is equal to 300 radian per second. And the time period between the acceleration is applied is 0.08 second. Now we have to find out the angular acceleration. Can you find it? What should be the expression for angular acceleration here? Just common physics we have to apply here.
Change in angular velocity by change in time.
Exactly. So change in angular velocity 300 minus 100. Change in time is 0.08.
Sir, change in time is 0.08 seconds, right?
Yes.
8 seconds.
So it should be 2500 radian per second square. Okay, any doubt here? Next part is,
Understood, sir.
yeah, you are also getting same? Yeah, next part is to calculate the torque generated by each phase. What is the expression of torque? Let me show you the statement of the problem. So external torque is given, okay, plus this acceleration requires some torque, isn't it? So in terms of d omega by dt, will you be able to find out an expression? So T will have T shaft, which the amount of load is present, on top of that, this much acceleration also it has to cater. So
J
because
into
of
d
that,
dt.
exactly. So J d omega by dt is also a torque function. Now shaft torque is mentioned here, 0.15. J is given 2 into 10 to the power minus 4. D omega by dt we have just calculated, which is 2500. How much will this come out to be?
0.65, sir.
0.65.
0.65. Yes.
So this component is predominant here. Okay. So how much torque, how much acceleration you will require, that will vary according to the second term, right? That's why it is also known as dynamic torque. Now, the third part is to find out the peak flux per pole pair. So let me show you a statement again. So what is the expression of peak flux, or flux rather? We have also calculated torque, acceleration, every data we have. So in terms of torque, do you know any expression? Torque is directly proportional to flux and current
Yes. Hmm.
and the angle between them, isn't it?
Then K T equal to K will come as a constant K phi IA.
Yeah, so T is equal to K phi
Or constant.
Ia sin phi. And K here is P into N. P and N is P number of poles, any number of turns per phase. Okay. So peak flux yeah. Now torque we have calculated, which is 0.65. Number of poles is 2. Number of turns per phase is 1000. Armature current IA is 2 ampere. Sin phi. So what should be the value of sin phi?
4 factor.
Uh, this is not power factor angle.
Cos phi is 4 factor.
Yeah, it is actually the angle between flux and current, between magnetic
Sir,
loading
then
and yeah.
can we take like sin phi equal to 1 with phi equal to 90 degree?
Yeah, that is correct, but that contradicts one logic, because here we need to calculate peak flux, and this flux value will be maximum at minimum
Phi.
value of sine phi according to this expression. But generally what happens from physical point of view, that if the angle between flux and current is maximum, then only torque will be maximum and flux linkage is maximum. So here we should put sine phi is equal to 1, which means phi is equal to 90. That condition gives you, maximum flux linkage or maximum torque. Right? So do not get confused that sine phi is coming in the denominator of the equation, because equation is just a way to express the relationship between all the quantities. Okay, so you are correct. We have to plug in phi is equal to 90 degree.
So sine phi 1.
Yeah.
(1.625 into 10 power minus 4, sir.
1.625 into 10 to the minus 4.
Webers. Nice.
Okay. Yeah. Oh, sorry. One mistake I have done. Here P is not number of poles, it is pole pairs. So we have to divide
1.
it. Yeah.
So now 3.25 into 10 power minus 4.
Sir, what is P here?
Number of pole pairs. Number of pole pairs.
Okay, sir.
I hope all three parts are clear to you. Any final question in this? Okay, so next question is, it is a theoretical question that efficiency of an axial flux SRM depends on rotor diameter, stator winding configuration, magnetic material used, air gap between rotor and stator. If rotor diameter will increase, of course, rotor losses should come down. So that's another thing. But here, which factor will majorly influence the efficiency, primarily influence the efficiency? So indirectly, all four options should improve the efficiency depending on the placement. But which primary factor is very important in the efficiency?
Sir, magnetic material used.
Yeah, magnetic material is important. That would play a role up to certain extent, but the most important parameter is the air gap which we can
Air gap between stator
minimize.
and rotor.
Yeah. So option D, if you see such problem, option D you can. Okay, any doubt here? As I
But by
mentioned that
looking, all the parameters are very important because magnetic
exactly,
material is really like very used, and the winding configuration also important. Everything looking like same, sir.
Yeah,
Very
yeah,
equal
yeah, as
important.
yeah, right. You're correct. Another thing is that they may change the cost, but here with air gap modulation, you could maintain the efficiency without cost. Only thing is that it will be complicated beyond a certain point to maintain air gap. Like generally, the minimum air gap I have seen is 0.3 mm. Below 0.3 mm does not seem feasible, but still maintaining that much small air gap is a huge thing. So all the parameters influence your efficiency, as you correctly pointed out. But we have to choose the optimum option. And as of now, I am also not convinced, but this is the answer which people have been, opting out. So that should be it.
Fine, sir.
So let's move on to the next problem. Stepper motor has a stall torque and inertia is equal to 2 into 10 to the power minus 4 kg meter square. What should be the stepping rate here? In terms of stall torque and inertia, there should be one expression, right? So that expression is derived as 0.539 into 386 into stalling torque divided by inertia. Okay, if you want to know how it is derived, go to the lecture and scroll there how it has been derived, or you could look at any other platform also. Okay, now have you seen this equation before? Any of you?
No, sir.
Okay, so just go and try to derive on your own. You will get to know how it has been derived. So stall torque is 1.5 divided by 2 into 10 to the power minus 4.
290, sir. 290.01.
290.01. So this is the stepping rate of a stepper motor.
So stepping rate 290.
Yeah, based on a stall torque, which is much higher than the what is the normal torque. So that is why. Because if you have to apply the brake, you will have to take higher steps.
Steps.
Because there you do not have flexibility to consume time while taking the brake. So that is why. Okay.
Okay, sir.
Now the last problem is, I believe, is repeated, but anyway, it is mentioned. So two phase, two poles, PMS stepping motor. So since it is repeated, you will have to let me know the answer. Number of turns is 800 turns per phase. Loaded with external torque, shaft torque is 0.2 Newton meter. rectangular waveform IA, IB is equal to 3. So I hope by now you must have guessed correctly which question is repeated. Inertia is changed 1 into 10 to the power minus 4 kg meter square. Okay, accelerated from omega 1 is equal to 200 radian per second to omega 2 is equal to 400 radian per second. Okay, during time is given as 0.06 second. Now, again, first part is to calculate angular acceleration. Part B is torque. Okay, so you'll have to let me know the answer for these two parts.
Sir,
Yeah.
angular acceleration is 3333.33 radian per second, sir. Second square.
Oh, wow. Yeah, that's correct. 3333.33 radian per second. Yeah.
And torque is 0.533 Newton meter, sir.
Torque is 0.533 Newton meter. You are close, but unfortunately, that is not the answer. How are you calculating?
0.507 I got, sir, torque.
0.507. And you, Chitu, how much you got?
0.533, sir.
0.533.
And
Okay.
I'll
Yeah.
okay.
Okay, I think some of you are correct. One of you are correct. 3, I think 0.533 should be correct because
Yes.
3333 is that, so 0.533 is correct. Isn't it, Rajni? Which one of yours?
Sir.
Yeah.
Yeah, it's only correct. The 0.533 only. I took that wrong Ashton value. Correct, 0.533.
Yeah.
Chittu is correct, sir.
Yeah. So this is all assignment problem which is given. So any other doubt apart from these problems? You can take, otherwise I can take some other problems which is mentioned in the lecture.
Sir, in the last assignment, one question I have doubt, sir.
Yeah.
Like we have calculated with that aligned inductance and unaligned inductance, no, sir?
Which exactly which question?
Sixth question, sir.
Sixth
With the
question.
stator pole arc is 20 degree and the rotor pole arc is 22 degrees, sir.
Yes, yes.
Oh.
Right. So here 6 stator poles, 4 rotor poles. A stator pole arc is 20 degree, rotor pole arc of 22 degree.
2 degree.
Aligned inductance is given, unaligned inductance is given. Okay.
Hmm.
And instantaneous torque. So I believe I have solved the similar problem.
Yes, sir. I got the answer like 2.3925 Newton meter, sir. But that answer is also wrong, sir.
Yes,
Oh,
sir. In my condition also same thing happened. I given 2.39 and they given a range is 3.2 to 4.
yes, that I can see
And we
the
don't know
range.
that is wrong, sir. 2.39. I also given 2.39 there.
Yeah, okay. So let's do one thing. We should solve once and just get short of that. So it is a sixth problem, isn't it?
Yes, sir. It's a sixth
Yes,
problem.
sir.
Stator pole, rotor pole, instantaneous torque we have to calculate with current given 30 degree before the aligned position, right? So first we need to find out the position of alignment and position of unalignment, right?
Yes.
Yeah. So what should be the position of unalignment? That should be half.
Half.
You'll have to help me here. Half
2 pi
into
by 4.
2 pi by 4, that is rotor pole, right?
Yes, sir. Minus
Minus
stator angle plus rotor angle.
a stator angle plus
Stator
rotor
pole
angle.
arc. That, yeah. Stator
Yeah.
pole arc plus rotor pole arc.
Okay. So how much is that in radian or even angle also? If angle is mentioned 20 and 22, we will take directly that.
I have
Half.
converted to radian and calculated, sir.
Okay,
Is
sir.
that
Okay.
okay?
Yeah, yeah. You let me know the radian. How much radian is beta S?
0.3839.
0.3839 plus beta R
0.349.
0.349.
0.349. Let me just verify it once. 20 into pi by 0.349 is beta R. And 0.3839 is beta S exactly. So how much is it coming after calculation?
0.419, sir.
0.419. Okay. Point 419. Yeah. Now this is unaligned inductance.
Yes, sir. Aligned position now.
Yeah. Now aligned inductance. So what should be the expression of aligned inductance?
Unaligned inductance plus it is before the 30 degrees. So the rotor 30 degrees before aligned condition. That angle also.
Exactly. So 0.419 plus, am I right? 0.419?
0.5235, sir.
5.
0.5235. This is,
It is aligned the position, right, sir?
sorry,
This
this
is
is 30.
aligned the position, right?
Yeah, this is aligned position, not inductance. That's why I have written theta 2.
No, in the topic you have given like aligned inductance, so I got little confused.
No problem. It is just marked there to, the process of calculation of aligned inductance. Anyway, to avoid confusion, just delete it. Okay, so theta 2 is written correctly.
0.929424, sir.
0.9424.
2.5. Okay, 2.4.
Point 9425, yeah, 26. It is coming around 0.94259, so 0.9425 should be just to get sure of the calculus.
0.9425, sir.
Yeah. Now, how to calculate these
Slope.
inductances? Slope.
Next slope we have to calculate.
Because to calculate torque, I square dl by d theta. So dl we have been given, right? Aligned and unaligned, sorry, here. Aligned is 110.7.
Unaligned is 10.5.
10.5
By
divided by theta 2 minus theta 1.
0.9425.
0.9425 minus 0.419.
419. 0.191, sir. But we converted this one.
It is coming 191, isn't it?
But
191.
millihenry, no, sir. So we convert into Henry, sir.
Yes, yes. So 191 into 10 to the power minus 3, so
10 into 4
0.1.
minus 0.191. Yes, sir. That one only we got.
Henry per radian. Now torque, half I is 5 square.
5 squared into 0.191. So 2.39, sir. Answer.
2.39. Yeah, 2.39. And the range is 3.2 to 4. So I believe it is not given correctly. The range of answers. I think they should increase. So you could challenge this problem.
Okay, so this question and that commutation frequency also is there. Now, sir, these two questions
Yeah.
better to raise a query actually.
Yes,
in the
yes.
portal.
Right.
Sir, one more question also, there is a issue is there, sir.
Yeah, which problem?
That state pole height question, sir.
Chittu, for pole height question, my question is wrong. Answer is correct, 33.974.
Oh, how much you are getting, Chitu?
Chittu, how much you got?
44.5, sir. We solved in the previous problem solving session, sir.
That
Right, right.
33.974 answer. Chittu.
I got some other answer. I don't know why.
Anyway,
Could you solve it, sir?
in the end, we will see that also. So in the meanwhile, in the question you both have doubt, we can solve that first. Okay?
Yes, sir.
Yeah. So which other question you were saying, Rajini?
Sir, I'm telling that one. Question number 4.
Question number 4.
A total MMF is 20% more than the MMF in the air gap of
Yeah,
twice
yeah,
the 4
yeah.
phases.
Yeah. How much you are getting?
Sir, I got 1.145.
Okay.
Yes,
Which
sir.
means you
Approximately 1.2 Tesla, sir.
okay,
I
you are
given
also getting
1.2 there, and correct answer is 0.5, sir.
Yes, sir. That question I am also having doubt, sir.
okay. So let us solve this and see what is the issue here. So question 4 is right. So number of turns per phase is 4 phase, right? So 500 divided by 4. So 125 turns per phase is the total number of turns. Now total MMF per phase we have to calculate. How much it should be? Total MMF
125 into 35 amperes, sir.
125 into 35 ampere.
So
Yes.
4,375 ampere turns, sir.
Okay. 4375. Right. Now, okay, I got it why it must be wrong. I got it. Uh, yeah, so again, I believe solution is wrong because it is mentioned that total MMF is 20% more than MMF in air gap, right? So MMF in air gap, so total MMF is 20% more. So MMF in air gap, it just, wording. Total MMF. It should be like this, right? You also applied the same relation.
Yes, sir.
Yes, sir.
MMF in air gap is
Sir,
total.
here I
Yeah,
have a doubt.
yeah. Go ahead.
Do we assume that the air gap MMF is equal to 1 here?
Air gap MMF is equal to 1 because we have to calculate in terms of air gap, right? It is in the question only it is said that total MMF is 20% more than MMF. So how will you write 20% higher than something? So you'll have to assume something is 100% and 20% more. So yeah, I have assumed here as one. What did you assume?
Same, sir.
Same,
I
right?
have also assumed.
Yeah.
Yes, sir.
So how much is it? 4375 divided by 1.2.
3645.83, sir.
Okay, so this much is the total MMF in the air gap, right?
Yes, sir.
Now H into 2Lg. I have also explained the logic behind twice of air gap in a magnetic circuit. The air gap will come twice, right? So that is why
Yes,
H
sir.
into Lg is equal to this MMF, 3645.83.
Yes, sir. H
Now
equal.
H you will get here. That will be 3645.83. 2 into Lg is 2 mm. So how much is it coming?
9,11,457.5, sir.
Okay, so 911458.
457 point.
Yeah, close.
Yes. Okay, sir.
Okay, now
Okay.
we can have B is equal to mu naught into H.
One point 145, sir.
1.145.
1453.
Yes.
But the answer is 0.5, sir.
Yeah. So I'm also telling you the reason behind 0.5. What they have done in solution, which I might have mentioned in the last session also, that in their solution manual, they have done one mistake that MMF in air gap they have calculated 0.8 times, whatever is the total MMF. You got my point. So they have done. Right, and ideally, how much is it? 1 divided by 1.2. Ideally, it is 0.833. So because of that, so much difference might be coming. I am still not sure if we calculate from this way. Let's see with 0.8. So 0.8 into 4375. 3500. Okay. It's 75. B is equal to
Sir, it is 1.0995 Tesla, sir.
1.0995 Tesla. But still, it won't fall in that category. So the simple thing is to challenge it according to the first solution only. It should be correct. 1.14 is 145. So clearly, it should be equal to 1.2 Tesla, right?
Okay.
Even by this approach, which certainly do not is not correct according to the question, but in previous solution manual they have provided this way. So that is why I thought they might have mistakes. So many mistakes are coming out. I don't know how.
Actually, I dropped a question, sir, last time. Solutions, when release the solutions, sir.
Yeah. So they might have replied something, no?
Yeah, I got a reply. We will provide shortly.
Okay.
Because if solution is there, then we can compare. No, means what we did wrong anywhere. Like we can get some idea about that.
Exactly.
I think last year also this course is there, na sir? The same.
Yeah. This course was there last time as well.
Okay, so at the time solutions released, sir. Have any idea about that?
Last time I was not the TA, so I cannot comment anything. But finally they released the solution. That much I know.
Okay. If solutions are there, then we can compare, sir. Because every time we cannot raise a questions.
Yes.
In this only, there is a 3 questions are coming like that, sir. In last
Yeah.
assignment, okay, no problem. Last assignment, perfectly all right. Next.
Okay. So that 3 problems had the issues, right?
Yes,
So
sir.
yeah. So keep in mind or note somewhere else when the solution should release, you should be able to, because anyway you will have to write to them.
Yes, sir.
Because
Compulsory.
if they have published such kind of answers, so they might be publishing solutions according to these answers only. So you might have to communicate with them
Yeah.
that these are the wrong questions, wrong solutions. Okay. Okay,
Yes,
now
sir.
coming to the Chittu's problem, which was a stated pole
That's
height.
last one.
Yeah. So how did you calculate it, Chittu? You'll have to help me here. Question 10.
Yes, sir.
Yeah. So how did you calculate a stated pole height?
Sir, the difference between the stator outer diameter and bore diameter I have taken, sir.
Yeah. Sorry,
After that, I
divide.
have divided it by 2, sir.
And you did not reduce the yoke height?
No, sir.
So that's where you committed mistake. In last session, I drew also, if you remember correctly.
Yes, sir.
Yeah. See, so this one is the
Back iron thing. Yoke thickness.
entire stator length, and you have to reduce this yoke, this length. You had to reduce this length also. Outer minus inner, that you did fine, but You are getting it right. Outer minus inner, that you did fine, but you did not reduce this yolk thickness, right? You got where you committed mistake.
Yes, sir.
Yeah, you should have just followed whatever I wrote here. Anyway, that's not a big of deal, but do not lose chance in your pocket. See,
33.98, sir, you got.
yeah, here last time 44 mm. It is stator height, right? So second C part.
Third one,
Yeah,
sir, last one,
yeah, third one.
33.98.
Yeah, see, this was the same problem or what?
Yes, sir, same.
Say-
I
You should
missed
have.
this part, sir.
You were present, I guess. No?
Sir?
You were present in the last session, right?
Yes, sir, I was present. I have just missed this part. I think I got disconnected.
Okay, no issue. That's not a big deal. But keep in mind, if you are getting the same problem, then no need to do so much jugglery. But anyway, you applied on your own, so that's a good thing. You tried on your own. So if I hope you got the idea where did you went wrong. But anyway, if you
Yes,
want to
sir.
verify, you again can watch the lecture or see the notes again if you want.
Yes, sir.
Okay. Any other issue from the last assignment?
No, sir, this much.
Yeah, number of
Sir,
power.
now
Yeah, yeah. Go ahead.
for calculating commutation frequency, now which formula we have to use, sir? Is it like NS by 60 or 120 F by P, sir? Which one would be appropriate, sir?
In lecture itself, the expression they had mentioned is this one, right? So according to their lecture itself, we should apply this expression only, 120 F by P, right? But which other expression you are referring to? That 60 is what?
Yes, sir.
Um,
Uh, what is that expression?
Instead of 120, they kept 60, sir.
Oh, then it is coming correct or what?
If they put 60, it will come in, sir.
Oh,
Exactly, it is off of that, double of that one.
yes.
333.33 came. There its answer is 666.
I took this expression from their lecture itself, so I don't know what is happening. I think we should refer some third party, like some other standard textbook.
But in any test, put computational frequency is used to go by this formula only, na, sir. 120 FAP, like.
Yeah, right. It is
Mm.
like in a 120 F by P only. I don't know. No, so you should not see, Kitu, you should not tweak yourself according to the given answer. The answer may be wrong, but for lifelong you will
Yes, sir.
remember the wrong expression, right? So until
Yes, sir.
unless this is ending and we are finally convinced that no 120 F by P is wrong, then only you should say, right?
Yes, sir.
Even then, even when the answer is wrong given, you should not follow because that is the answer given. So see, this week itself you got 3 problems wrong. So how many times you will change your convention according to the given answer? So you stick to the
Just to
120
get
F by P.
clarified, I asked, sir.
No problem, no problem. So just follow this 120 F by P, right?
Okay, sir.
Okay. Any other doubt from the? I was asking about this asymmetric bridge. So you know how many switches are used in asymmetric bridges, right?
Yes, sir.
In 4-phase SRM, there are two power electronics controlled switches like IGBT or MOSFETs per phase, and two diodes, anti-parallel diodes per phase.
Phase.
So 8 switches,
Total
controlled
8.
switches, and 8 uncontrolled switches should be there. So since they asked only IGBT MOSFET, so you could have correctly mentioned 8, isn't it?
Yes, sir.
Chitu, you also filled 8, or you knew this thing, right?
Yes, sir. We given 8 only.
Okay,
Yes, sir.
okay, great. Okay, so let's solve some other problem. Since we have time, we can discuss some other problem as well. So, a stepper motor has a step angle of 2.5 degree. Okay, we have to calculate resolution. What is the expression of resolution here?
Three 360 by beta, sir.
Yes, exactly. 360 by beta. Beta will be a step angle. So resolution should be 144 steps. In a revolution, there will be 144 steps, right? So resolution is like in a revolution, how many steps it is taking to complete it, isn't it? So according to that, we have to calculate. Now, the next part is how many steps required to make 25 revolutions. So you just need to multiply with 25. When 25 revolutions, so how many steps? So it should be 144 into 25. So 1440 to 880 into, so
3600, sir.
3600 steps, right? And the next part is how much should be the shaft speed if a stepping frequency is 3600. What is the expression of shaft speed?
120 up by
120 F by P is fine, but we do not have any number of poles provided.
Beta F by 360, sir.
Yeah, beta F by 360, exactly. So beta is our step angle, how much step angle it is making, and how much is the frequency. So 3600 divided by 360. Right. So in a cycle, number of steps into frequency, right? And it will give you what? RPM or RPS?
RPM, sir.
No, it is RPS. Why RPS? Because it is frequency only. No, 3600 is only frequency. If you take inverse of frequency, it is second. If you want
Okay,
to
sir.
convert RPM, you'll have to multiply with 25 into 60, 1200, 1500 RPM. Okay.
Yes, sir.
Okay. The next problem is, multi-stack stepper motor. So in multi-stack stepper motor, number of rotor teeth is equal to number of stator teeth. Okay. Now, this question has given that a VR stepper motor has a step angle of 1.8 degree. Find the number of rotor teeth and stator teeth. And this 4-stack VR. It is 4-stack VR stepper motor. Calculate the number of rotor teeth, then automatically you will get the number of stator teeth, which will be equal to the number of rotor teeth. Okay, so what is the relationship between number of rotor teeth and a step angle in this multi-stack stepper motor?
Both are same, na, sir, means number of stator.
Number of stator teeth is equal to number of rotor teeth, but what is the relationship between a step angle and number of rotor teeth? You got my question?
Step angle equal to 360 by M into NR.
Yeah. Yeah. And M will be here. How much the
How
stacks?
many?
Yeah, how many stacks are present? So M will be 4. Step angle is 1.8 degree. And now you can calculate. Oh, sorry, 360. 360 degree divided by.
360 to 4.
Okay. So 1.8, 3.6, 7.2.
50.
7.2. So it will be 50. So number of rotor teeth is equal to 50. And since it is a multi-stack motor, the same will be a stator teeth. So it will be 50. Kitu, you got it?
Yes, sir. Sir, here M means number of stacks, sir.
Exactly. M here is number of stacks.
Yes, sir.
Okay. So next is a single stack four phase multi-pole. Number of poles are not mentioned. A stepper motor has to provide 15-degree step motion. Okay. Now we have to calculate rotor poles and stator poles.
Sir, rotor pole 6.
Rotor pole 6, exactly. You'll have also let me know the expression of rotor poles.
Sir, step angle beta equal to 360 by m into n, sir. Same formula.
Step angle is equal to
360 divided by
m
m
into nr.
into number of rotor poles. Yes, sir.
Yeah. So here m should be number of phases rather than number of stacks.
Yes, sir. Number of rotor.
Number of phases.
Number of phases.
Yeah. So beta is 15 degree. NR is 6 rotor teeth. Right. Now, how much should be stator teeth? NR minus NS divided by NR into NS is equal to how much?
15 degrees, sir. Here before.
Sir, 8, sir. Rotor poles. Stator poles 8.
Stator poles 8, yeah. So the relation of a stator pole is
NS minus NR by NS into NR into 360 degrees.
NS
If
minus
N is greater than NR.
Yeah, we will take mod just to simplify. Into 360 degree is equal to NS is equal to beta, right?
Beta angle. Yes.
Yeah.
Step angle.
So NR we have calculated. So NS minus 6. Still we will have to take mod. So 6 NS 6 NS
Into 360.
into 360 degree and beta is 15.
15 yes, degrees.
Six is equal to
60
yeah, 64
force.
is equal to NS by 4. So 3 NS by 4 is equal to 6. So n is equal to
8.
Okay, got
Okay.
it? Yeah. Okay, so this problem we'll solve one more time. This time we'll have to
N is
calculate.
greater than n, less than n hours.
Yeah, so here ns is higher than nr.
NR greater, oh, this is NS greater than NR condition, sir. Now one more condition, na NR, NS less than NR.
Yeah. So in that case also you can solve in similar manner, right?
Same, sir, same way.
Same. Yeah,
Instead of NS, NR, they just opposite to each other. That's
right. So always beneficial to take mod of this.
mm. Mhm.
Okay. So
Okay, sir.
we'll solve one more problem.
Yes.
It is a quite lengthy, but cylindrical. Okay. So this. Okay. So a three-phase single stator double rotor axial flux SRN. Rated speed is given 2000 RPM. Okay. Geometric parameters are mentioned. So let me tell you the geometric parameter is D1, D2, D3, D4 and beta R and beta S. So first beta R is equal to beta S, which is rotor pole R is equal to stator pole R is equal to 30 degree. And uh, yeah, so what shaft diameter is D1. Shaft dia is given 40 mm. D2, which is a stator bore diameter, is 70 mm. D3 is uh, length up to where the stator yoke is ending, like this fashion. right? So up to from center to here. Okay. So till yoke is starting, that diameter is D3, which is given 90 mm, and D4 is stator outer diameter. 110 mm. Okay. Now a stator and rotor stack length are not same. A stator stack length is equal to 60 mm. Why are not? Why both of them are not same? Rotor stack length is 20 mm. Generally, in radial flux machine, both are same, a stator and rotor stack length. But here, since it is a axial flux machine, right? So they are not same because they are placed axially. So length would vary, but their diameter should be like similar. So in axial flux machine, the flux will travel through the axial length, and since it is a single stator double rotor, right? So two rotors are placed outside and one stator is placed inside where windings are done. Right. Now, air gap is 0.5 mm and number of turns per phase is 32. So this much data is given and some other parameters like KE efficiency constant is 0.8, KD 1, K1 0.0823, K2 0.7. Electric loading is 20 kiloampere per meter. Magnetic loading is 1.5 Tesla. Okay, so data is exhaustive, I believe. Now we need to calculate flux linkage at aligned position. So the equation of flux linkage at aligned position is magnetic loading into first pi by 4 factor into magnetic loading into d4 square minus d3 square into beta s into turns per phase. Okay, so here I believe we can calculate the flux linkage. D4 is mentioned as 110, right? And D3 is mentioned as 90. So can we calculate it?
Sir, D4 square minus
D3 square.
D3 square, no, because it's a whole square editor. That's in the
Yeah,
expression.
it is D3 square only. So see, when the stator poles and rotor poles will be aligned, right? So at that instant, the length would be or diameter would be from the center to the yoke where the yoke is ending, right? So since it is a single stator double rotor, uh, here rotor, here stator is wound, here again rotor. So at aligned position, both tooth, tooths should be aligned here, right? So the flux will come out of this like this. Okay, so this is how double rotor single stator will be wounded and how the flux will travel. So D4 is the total diameter, and we are reducing D3 out of it. Let me see the. Yeah, so which parameter you were saying to reduce? Instead of D3, which parameter you were recommending?
No, I'm not recommended. I'm telling that actually expression is D4 square minus D3 square and D3 whole square. Like it's a look at like
Okay,
whole
no, it is D3 square.
D3
Yeah,
square.
yeah, yeah, yeah. In the problem, geometry is not clearly mentioned. I don't know. If you go through the lecture 37, you will see this problem there. And geometry should not be like that of double rotor single stator. But anyway, according to the expression, we can calculate.
Sir, it's a 4.52 is coming, sir.
4.52.
Like here angle is 30 degrees, no beta r equal to beta. So I took
Yes.
degrees only. Can I change it to the radians?
You can change. Yeah, radians would be appropriate here.
Yes, sir.
Yeah. So let me also parallelly calculate it.
Yes. One 1.5. Yes.
Into
110.
D4 110 square.
Yes, sir. 110. Into 10
Minus
more minus 3 also you can return, sir, here.
Yeah, it is in mm, so 10 to the power minus 6
Minus
should
3.
be.
Minus 6.
Beta S is 30, so 30 into
30 into pi by 180. Yes. 32 turns per phase.
into 32.
0.078 is coming, sir. You can count.
0.078 Weber.
Yes, sir.
Yeah, it is correct. Anyway, okay, so we'll keep problem till this point only. But what is the advantage of using axial flux machine over radial flux machine?
Within less area, we can get more torque per rotor volume, no, sir.
Okay, okay, agreed. But
Taking very
why?
less space, sir.
Yeah, but why?
Because we are having one stator and two rotors, no? Like we are utilizing all the flux properly. Like
Okay, so if we have one stator and two rotor, then we also have two air gaps.
mm,
So if number of air gap is increasing, which will be, major factor to reduce efficiency and performance. So if you compare any machine with single air gap and double air gap, so which will be more efficient? Let's suppose you have constraint like you can go up to 0.3 mm of air gap, and then you have to make one machine with single air gap with 0.3 mm and other with double air gap with 0.3 mm. So effective air gap would be 0.6 mm. Though you are
yes,
reducing the flux path along the axial length, but you are also increasing the air gap, isn't it? And air
yes,
gap requires majority of MMF corresponding to the core.
yeah.
So that's one thing to think about. And other thing is that straight away axial flux machine does not take less volume because what will happen that yeah, whenever your L by D ratio is small, means you want to make machine with a small axial length and you do not have constraint over the diameter of the machine, right? Then axial flux machine is attractive. On the other hand, if you have constraint on diameter, but you do not have constraint on axial length,
Stack length,
then
length.
a stack length, yeah, then you should opt for radial flux machine. And this there is one ratio that L by D is some 0.6 or something. Beyond that, you should go for radial flux. Less than that, or you should go for axial flux. So, yeah. And other important challenge in axial flux machine is what? Why we went for double air gap in axial flux machine? Do you have any idea? We could have maintained with single air gap, isn't it? So let's suppose you have one stator and you have one rotor. So there is air gap. Okay, flux is moving like this from a stator to rotor. Rotor has magnets and all, just for time being. Okay. So what should be problem here? Why you commonly not see such kind of topologies?
Like space constraint only, na sir?
Then if I am removing one rotor itself, then
Hmm.
I'll be able to save more space, isn't it? But still people go for
One more
double one
double.
more rotor. Yeah. So have you heard of unbalanced pull? So since permanent magnet is there, it will also exert force, a strong force.
Hmm.
So because of that, both stator and rotor will not be able to
Align.
align properly. There will be always mismatch or unbalancing between them. So that is why what people did, that people again placed one more rotor so that there should be balanced force. The amount of force is created by left hand side rotor, same amount of force should be created by right hand side. Sorry. So the force should be maintained, and the issue of this pull, unbalanced pull, should be mitigated, right? So
Oh,
you might be seeing many companies are opting for axial flux machines, but this machine exists from more than 100 years. But now people are opting for such machines. So only reason behind this machine hasn't matured enough because of this unbalanced force. So balancing this machine is very tricky.
okay.
And also there are a lot of papers which also mention and compared the efficiency between this and radial flux, and it is not a straight away advantageous. Like otherwise, all the vehicles would have axial flux machine by now, because there are a lot of designers, lot of industry. So we would expect many vehicles axial flux motors are present, but because this motor has been existing for more than a century, so that's one reason why it hasn't been adopted widely. So after this week, there will be lectures on
Okay.
finite element problems. So have you tried the software FEMM?
Which software, sir?
FEMM, it is open source software.
Okay, axial fluctuations related. Okay.
No, no, not Tiger Flux, related to any machine, any common surface mounted BLDC also.
We go
This is
for Flux, sir. Flux software and Maxwell.
okay.
Finite
Yes,
element analysis, the two softwares.
okay. Uh, in next week, from next week onwards, lecture will be based on FEMM, which is why they have selected FEMM software, because it is an open source package. So
Okay.
anyone could solve, or anyone could use for free of cost or from anywhere.
Okay.
So I think
So where it is, sir? Software means so how to have like access it.
you could download it. I think all the instructions related it will be provided to you. If not, then in the next session we can install it. We will start the session based on how to install and all, right?
Yes, sir.
You first try to install on your own. If you are not able to install, then we will see, and we will be able to solve some
So
simulations.
no, just to show me what is exactly site, sir. If you show me the site, what I will go there and I will install it, sir.
Yeah, yeah, just a second. I'm presenting my screen so you will be able to see.
FEMM.
Yeah, are you able to see FEMM?
Ah, yes, sir, I can. FEMM.
So this is the software finite element. That's magnetics. So here you could go on the download tab, and for 64-bit,
Okay.
you'll be able to download this. Then certain instructions are mentioned, you could follow. Release notes on the page. So this is how you will be able to get some example. So this example you could follow from here. Air gap boundary condition, boundary properties and all with diameters. Like that. So MATLAB file is given. So it could be coupled with MATLAB as well. You have MATLAB access, Rajini?
Actually, in my MTech, I have MATLAB here. MATLAB access is there. Now I don't know. In office, we
Okay,
have MATLAB, but it is used by electronics people, not for us.
okay,
It is
okay.
dedicated
No,
to another department.
no issue. So without MATLAB also you could just directly go to the software, and I hope you'll be able to run.
Means what are the parameters we want to calculate? Then I can do in the known softwares also, no, sir, like MotorCAD,
Yeah,
Flex,
yeah,
Altair
yeah,
software, ANSYS softwares, and
exactly. You have
even Speed also is there, sir. I have Speed also, Speed software.
so many softwares your company has brought.
We are having so many softwares here. We are having OptiSlang for the optimization.
So they your company pays for so many softwares, like for all the softwares.
Yes, sir. For all the software we are paying. We mostly purchase all the softwares what are required for motor design and magneto
Uh,
design.
like generally, company purchase one software hardly. So that also for limited licenses, as far as I have heard about some MNCs.
Yes, sir. Because what is happening, sir, one time we purchase not is sufficient. Every year you have to pay the maintenance cost also, annual maintenance cost.
Oh,
Every year you have to pay compulsory, sir.
oh,
That is the reason, like it's not a one-time like investment.
yeah. You have to pay annual.
Pay annually, you have to pay. But still, we have all the resources. So
Yeah, that's good to know. So you might be fluent in all the softwares.
yes, sir, I have like hand in all the softwares.
Nice. So which software have you liked yet till now?
Altair, sir, Flux.
Alta Flux is very
Altair
handy.
Flux. Yes, sir, because it's very customized. The thing is, whenever we want to do in Maxwell or somewhere, we have to do in I mean, RM export. You have to import. That's a very easy actually. Coming to Flux, you can have to define everything. Geometry, you have to define like you have to extrude, define all the volumes, circuit, winding, everything like in our hand only.
Oh,
Little it will take little more time,
huh. Just
but
like
precision is I feel like more in Flux.
initial learning has a steep curve, but after that you'll get to learn. Like it will be handy as you are recommending. Nice. And how is the speed? The speed is by the Siemens, right? Or someone
Speed
else?
is by Siemens, sir, but it's a 2D software and it's a prolonged. There is no any development in that particular software. Actually, speed is same like MotorCAD. First, the speed came.
Okay, speed first came.
The developer of speed, he created the MotorCAD with a
Oh,
little more like colorful and thermal analysis also they added.
okay, okay.
Yes, MotorCAD is there. And MotorCAD to Maxwell connection is there. That is working very nice.
Ha, right, because ANSI bought it, no? So because of that connectivity is so good.
So good actually. We get immediate quick results.
Yes, yes.
But in
We did
coming
even
to Altair, like it's like a little hard work. It have to do create volumes. You have to define the volumes, and every step you have to check. Then only you can go to the next step. Geometry is okay. Then only you go to mesh. Mesh is okay. Then only you can go to physics. Physics okay. Then you can go to the solid scenario.
hmm,
Like there is a little more steps is added, but it's a very convenient software. Like anything we can do over there.
but on the MotorCAD, you straight away build your 2D model and export to 3D AutoSolve,
No,
and it will solve your
actually, here one more question, one more challenge is what is happening, sir? We unable to design the single page generator in MotorCAD. Not
single
possible.
yeah, because it is a template based, so you'll have to tweak in the geometry. So single phase, which generator you are trying to design?
Uh, BPM BOR, brushes permanent magnet outer rotor,
Okay, so
surface
you are
magnet.
not uh,
Like a
single phase.
PMDC only, like it's looking like
Yeah,
PMDC only, but it's a outer rotor one. Are they same? Like, but here it is a switching is like motor control we are using generator.
okay, okay.
That single phase is not possible, sir. Even though in RMX, but also not possible. I'm doing it some.
And have you tried tweaking with windings, like giving winding number of phases equal to one, like that? Something?
They actually what is happening whenever still calculation part it is okay, sir. If I give number of pages or one it is taking and okay. Then I went to the calculation part. I give as a passive generator because here it's not a motor condition, generator condition. So
Yes.
how to click? I have to select the passive generator. And whenever I select the passive generator, automatically it is converting from phase 1 to 3 phases, single phase to 3 phases.
Oh, whoa, I got your point. Yes.
So this query I already raised actually in
To
Maxwell also.
MotorCAD. Okay, to
They also
Maxwell.
connected with me and they told that we'll come with the answer. We'll come with solution.
Then that's good. Passive.
In calculation mode, it is there, sir, in passive generator. And I
Yeah,
saw
yeah, I'm there
calculated
only. And with custom mode, have you tried?
calculated currents and
Yeah, in calculated currents.
But actually calculated currents and I have to go passive generator compulsory. And here it is changing directly from single phase to three phase. We cannot do anything. Now, like compulsory, we need a single
Okay,
phase. The
okay,
winding,
I got your problem. Like you are selecting for calculated current, so
calculated.
that's why custom is not coming.
Calculated currents, then only we can go to the passive generator. Mine is generator condition.
Okay, okay,
In a
I
lab
got.
also, we can do like I used to try lab also. In a lab also, single phase is not allowed.
Hmm.
In lab section, we can do Nasir. There in
Yeah,
motor also there is having lab. No, there we can simulate it for motor condition, generator condition also for both like ISC, integrated starter and generator.
exactly. Like in calculation general, tab their operating mode as motor generator or motor
Generator.
generator.
Yes, yes. For three, one single phase is not taking actually. There is a like errors are
Yeah, it's good. Let me know also what they are saying.
there. Yes, yes, really. I also looking for that.
So I'm glad that I'm getting to learn from you also so much. So that's good. Thanks a lot for sharing your experience.
Yes, I too, sir.
Yeah. Okay then. So let's end this session and
Okay,
we
sir.
will meet again next week. Thanks a
Next.
lot for joining. Yeah. Bye.
Thank you,
Good
sir.
night.
Good night.